Yeah, like so just looking at this, balancing is annoying because sometimes you got to go back and forth and they have these rules. Don't do this first, don't do this first. Let me show you an algebraic way if you're good at algebra. Put an A, which represents a future number that we don't know. Put a B here, which represents a future number we don't know. Put a C here, which represents a number we don't know, and D here. Now look at each of the elements we see in here. We see an N, nitrogen. We see a hydrogen reading left to right. We see a oxygen again. We see a nitrogen. We don't need to write nitrogen twice. We see an oxygen again. We don't need to write oxygen again. We see a hydrogen again in D, and we don't need to do that. Now, we've listed them all, nitrogen and oxygen. Now, look at the left side, the reaction side. For nitrogen, how many nitrogens do you see in A? I see one, so I say 1A. Do I see any in B? No. Do I see any in C? Yes, I see one in C. And so I say 1A is equal to 1C like that. Okay. Now I'm going to look at hydrogen. Oh, I see 3 in A. And any in B? No. So I hit an equal sign. And do I see any in C? No. Oh, yes. Sorry, hydrogen. No. Do I see any D? Yes, I see 2D. So I do, for hydrogen, 3A is equal to 2D. Then I look at oxygen. Do I see any in A? No. Do I see any in B? Yes, 2B. Hit equal sign. Do I see any in C? I see 1C, and I see in 1 in D. So I say 1C plus 1D. Go back to your 1A, your A rather, and assume this. A is equal to 1. Now solve it algebraically. 1A is equal to 1C, but A is equal to 1. So 1 times 1 is equal to C, 1C. Algebraically, if I solve it, C must be equal to 1. So that means A is equal to 1, C is equal to 1. Now move on. Over here to hydrogen, I see 3A is equal to 2D, but I can see that A is 1, so 3 times 1 is equal to 2D. Divide both sides by 2, and I see D is equal to 3 over 2, which is 1.5. Now I'm going to move on to the last one. I see that 2B, which I don't know, is equal to 1C. Well, each C is 1, and 1D, which is 1.5. So I see 2B is equal to 2.5. So I see B is equal to 2.5 divided by 2. Okay, so just leave it like that. Don't do anything else. Just leave it like that. So I see these weird things. 1A and 2C is equal to 1. But I want whole numbers. So if I multiply this by 2, if I multiply everything by 2, what happens? So this becomes 2. This becomes 2. This becomes 1.5 times 2 is 3. And this one, which is 2.5 divided by 2 times 2, the 2's cancel. So that's still not good. As long as I don't have a whole number, I want to keep going. So I multiply by 2 again. 4, 4, 6, and 5. Now, if any of those can be reduced, then I'll reduce it. In other words, if they could all be divided by 2, then I'll divide them by 2. But it looks like A is 4, B is 5, C is 4, and D is 6. So I go back to the numbers I put in front of them. And I go 4NH3 plus 5O2 is going to react and create 4NO and 6H2O. Then add them all up again to make sure you got it right. I got 4 nitrogens and 4 nitrogens left and right. I've got 12 hydrogens and 12 hydrogens left and right. And finally, I got 10 oxygens on the left and 4 plus 6 on the right, 10. Balanced. This is the algebraic method. It works really well, especially for complicated situations like this. You keep multiplying your numbers until you get whole numbers whenever they're 2.5.